Good morning. Hope everyone is doing well and still healthy. I miss you all a lot. So today we are going to finish up this last unit that we need to do before we start really reviewing. And so what we're going to be looking at now are quantitative data. So all the tests that we've done so far have been on categorical data. And so now we're going to look at quantitative data. And the name of the test that we're going to look at today is the one sample t-test for the mean. So the first thing we do is write our hypotheses. So we write our null. Now the letter that we're using is the Greek letter mu. It's that one that kind of looks like an M and kind of looks like a U, which is where we kind of get the word, the name mu is the way I think about it. All right, and then that equals a number that we call the hypothesized mean. Just like we had with proportions, we had the PO, which was our hypothesized proportion, and we plugged in a number for that. So this is going to be very similar to the one sample z-test, or not one sample, one proportion z-test in the way that we do this. So this should be a number that you plug in here. And then your alternative is going to be that mu is less than that number, or that mu is greater than that number, or that mu is just not equal to that number. All right, so you do your hypotheses, then you do your conditions. And so then we have randomization, just like we've always had, 10%. We do not have success failure on this one, so some of you that don't do that one very well will be glad of that. But we do have nearly normal, just like we had with our confidence intervals for means. And so again, with nearly normal, your distribution needs to be unimodal and fairly symmetric. You may be given a histogram. You may have to actually draw a histogram on that. So you'll have to take a look at that. Then you write your statement. So this time you are going to perform a one sample t-test for the means. I think if you just say one sample t-test, that would be suffice what you need to. And this time we're using, since it's a t-test, it's not the normal model, it's the student's t model. And we learned about this when we did confidence intervals. Then you find your statistic. So this time you're finding a t-score. So it's the sample mean minus the hypothesized mean over the standard deviation of your sample over the square root of n. So this is how you find the standard error. So standard deviation of your sample over the square root of n, that is on your formula sheet. You do have to state the degrees of freedom when you do this, which is n minus 1, just like it was with confidence intervals. Then to get your p-value, you're going to do stat test 2. And depending on if you're given statistics or actual data, you will pick that there. So we'll look at that with an example. And then your conclusion will be the same as it's done for the other tests. So if your p-value is low, reject the whole. If your p-value is high, the null might fly. So same idea there.